Okay, but if you consider like TensorFlow, in the low level time, you have to write your own functions. Okay, the requirement might be that you have to write your own functions, but in Keras, it's like not too much easily you can do that. Therefore, you can only, let's say like you are just calling in the layers. In those cases, pretty good to use like Keras. So PyTorch is actually just a low level API. Actually, it is not so much of a high level API. Therefore, most of the times the amount of code that you have to write is much larger compared to what you have to write in Keras. So if I just compare the normal the languages that are down present usually, so Keras can be compared to something like Python or R, where you are it's very easy to write your code. Whereas like PyTorch can be compared to like C++ or Java, where there is a lot of code that you need to write whenever you're uh, trying to write your own code. PyTorch actually came out as a product from Facebook. So therefore, if I come to the ease of the code, then TensorFlow, I would say it's usually the medium. It's not too hard. It's not too easy also, because sometimes you have to write like a lot of code. And whenever this low level API comes, then it becomes like you have to write a lot of code. Whereas in Keras is actually like very easy to write the code. Something like whenever like you are writing in like Python, any other code that you want to write, you have to just call in the functions. So the similar thing is in like Keras when you are just calling in functions. Whereas like in PyTorch is usually a low level API. Therefore, the amount of code that you need to write is, if it is not too difficult, but compared to like Keras, it's obviously a little bit more codes that you need to write. So if I come to the speed, then TensorFlow is actually, both TensorFlow and PyTorch are very fast because they also consider a low level API. But however, since Keras is actually at the top of the TensorFlow, so it needs additional computation requirements. Therefore, the speed is not too fast when you compare to take care TensorFlow or PyTorch. But however, if you are just considering usual things that people want to do in, like, let's say civil engineering applications, that Keras should work good enough. So in this one, I will be actually going and focusing a lot more on Keras in this lecture, because it is like much more easier to use. So if you want to do the installation of any deep learning framework, each of these framework are actually like Python based. As you can also understand, like Torch, the name PyTorch is given because it's a Python based torch. Okay. Usually, as I say, that needs to be installed in GPUs. You can install in CPUs, in your own CPUs if you want. There are like ways, and if you just go into the TensorFlow website, they will give you the entire process of installation. But however, it will be like very slow if you are using in like CPUs. Uh, and the usual way that you can install is something like pip install TensorFlow, pip install Keras, and everything like that. Okay, so the details you can actually, if you're just going into, if you just search in the TensorFlow website or Keras website, they give you all the details of how to install. Just one thing to note: if you are using your own GPU, then the amount of installation that you need to require, the process becomes a little bit extended, obviously, because you need to install a lot more dependencies. Like GPUs depend on something called like CUDA, and sometimes for even like much faster processing, you need like QDNA. So you have to install those things previously and then go with installing these frameworks. Okay. Also, if you want, instead of your GPU, you can run in like cloud-based systems, so something like Amazon Web Services, AWS or Azure, or any other cloud-based systems that are present. You can use those systems for writing your codes. But however, like one way that you can do, if you're just doing some small testing or preparing a small amount of code, then you can go with something which is called Colab, Google Colab. I will just come into a Google Colab just in the next slide. But just one thing that I want to say before is, whenever you're going in the cloud-based systems, it's actually like very efficient, because you don't need to first of all like buy any physical hardware. And the second point, it usually, like whenever you require, you just build a virtual machine and you just work on it, and after that you just turn it off. But however, whenever you're going with actually GPU requirements, my experience has been that the amount of charge that's actually like given uh, for each unit of processing that you are doing is significantly higher. So even if you have, first of all, you need to buy your credits. Sometimes students, usually like AWS or Azure, you get some free base, but it will just go out like so fast, even if you're doing some small complex. And whenever you're doing cloud, you need to be like a little bit extra careful, so that you don't keep it like running constantly, because then you will get charged constantly. But however, like whenever you're doing a much more small scale built up, then like Colab will be the one that you can just work on if you don't have your own GPU, obviously. So what is like Colab? Colab is actually also came out from Google. It gives you a very efficient way of writing the code entirely in your browser. So something like Google Chrome or Mozilla or whichever browser that you are using, you can just open this link of collab.research.google.com, and then it gives you an entire this. If you look into this, it looks entirely like Jupyter Notebook. So on the background, it's actually running a Jupyter Notebook. One good thing is that it's actually like completely free, so you don't need to pay anything. If you're using this Colab, you can just open it and you can write your code and train it and work. Okay. And also very efficient is you can just share between your members easily, to just look into if everyone wants to like collaborate. Then, as you can also understand from the name, that if you want to like collaborate like multiple people, then it becomes like very easy to just share the code with your teammate, and then that person can also write their own version of the codes down in different cells or something like that. So it's based completely, if you look into the entire platform, it is exactly based on like Jupyter Notebook. So you have the own entire things of the cells, and you just run the cells to uh, get your outputs. So it uses Python environment with the Jupyter Notebook. And as I said, that a best thing is like it also comes with the pre-installed Python library. So whenever you are going with installing in your configuring your own GPU, you have to think of all these kinds of first installing CUDA, QTNN, and other pre-requirements, which sometimes if it crashes, then you have to like again load and install everything. So whenever you are doing like Colab, you don't have to think of any of this pre-requirement that you need to install before you're running your code. And I said it's like completely free, but obviously like there are like other constraints on it. So the usual constraint is, since it is like completely free, so therefore like there is also a runtime limit of, they say as like 12 hours, but it can also come down a little less. So what happens is actually like if you are running it constantly, then at some point of time like Colab will just kick you out of saying that no, like okay, you have enough like used enough resources, then it needs to be shared because all the peoples are also using it. So therefore they if you are going significantly beyond the resources or demand, what the demand is at that point in time, they might just kick you out at that point in time. So that is obviously one of the things that you need to think of. Is like whenever if you want to write let's say long code with a long amount of training, then it's not good enough, because after like maybe like 3 hours 4 hours or something like that, it might just, because of additional resource constraints, they might be giving to someone else, and then they might be just keep your code to stop. Okay. And also like if you are idle for too long amount of time, so the runtime will disconnect automatically to give the resources to some other user. Some of the issues that you might be facing when you are using the Colab is, as I say, that if you are using for a significant long amount of time, in those cases, they might Colab must just stop your code and then give the resources to some other user. So your notebook can crash. And as we had also talked a little bit about how extensive the training process can be, so like usually the training can easily go like multiple hours, if not multiple days. Actually, like when you're doing like imagine it goes into like multiple days or weeks. But however, for small scale applications, it may still go into like a few hours. In those cases, if your notebook is like crashing, then your entire training is like just crashes. Okay. So therefore, how you can do is every few epochs, you write your code the way that every few epochs, the training parameters are basically stored in your Google Drive. So you can easily sync your Google Drive with your Colab, and then like every few epochs, it creates a checkpoint with all the training weights being stored. And if in some case, like what can happen that if your notebook is crashing, then it will right away start from the previous checkpoint that it has already created. So that way that you can take care of the point that if your notebook is crashing, so that you don't lose the entire, let's say, like few hours of training that you have done. You can start right from the point when your last checkpoint is created. Also, one of the thing that happens is like whenever your runtime disconnected, so the entire data set that you are working on needs to be like again re-uploaded. Okay, so therefore it takes a lot of amount of time if you're just re-uploading the data again and again. Okay, the way that you can take care of this is you mount your dataset or you put your dataset in a Google Drive, and if you just search, you will find like how to connect Google Drive with Colab. It's just writing as just a small command, and then it automatically will connect to your Google Drive. And whenever you are restarting your code, then it can just directly take from the drive, and so you don't have to take care of uploading the dataset again and again, which takes a significant amount of time. So if I just look into also this runtime management, so at the top you will be able to see this runtime. So in the change, and if you go to the change runtime, you can actually change to, usually it's given as like none, but whenever you are doing this training and everything, you can change it to like GPU. When you are not doing the training, and if you're just simply writing a little bit of extended code or something like that, then you can just be with like none, because then the amount of time that you can be in Colab becomes extended. You cannot working with GPU for a significant amount of time, because then at that point they will give the resources to some other users. So whenever you're just starting to write your code, then I would say like go with just none. And then when you are doing the final training, in that case actually like go with the GPU. Okay, so then you manage your resources very efficiently. Okay, and also when you are writing your code, then I would say like just go with a small scale data set. First do that entire of this process of writing your code and then debugging. Once you are completely sure that it like works, then you train your model on the final large scale data set. Okay, so I will go through some of the Keras examples. All these examples you can actually find from this website, or keras.io/examples. It has a lot more examples that are down there. So I will just go through one of the very simple example. But however, if you whenever like you are interested, I would say like go to this link and you will get all the different types of deep learning things that you can basically do. So first of all, I would like to go with a very basic task of, let's say like you have to do like image classification from the scratch. So it's not something like transfer learning that you are doing or like fine tuning. Just starting from the scratch, you want to do something like image classification. Okay, so let's say like you consist of the data set consists of, let's say like cats versus dogs. You have to do a binary classification. It is a very popular and very initial binary classification that people usually like do and then test out their models of whether it's performing or not. Okay, so what is the step 0? In the step 0, you just import all the necessary libraries that you need. So something like import TensorFlow TS, from TensorFlow import Keras, and in Keras you have different layers, which are basically convolutional pooling layers that you are basically importing. So this is the first step when you are doing this importing. And this entire of this example that I will covering, you can get from this link of the keras.io examples, vision image classification from scratch. So I'm taking the code snippets directly from this portion. And if you go to this link, you will also see like a link where you can just directly open this entire thing in Colab, and then you can write your code directly in Colab. Okay, so now let's go with the downloading the cats and dogs dataset. So there is already a benchmark dataset that is like present, that's present in this link. So you can just download the dataset from there. It comes with a zip file, so you can just unzip right away in the note in your notebook. So when you unzip, you will look like it will look something like this. Okay, so it consists of this main folder called pet images, where you have 2 folders for cat and dog. Cat will consist of all the images of cat. They are like .jpg files. Similar, dog will consist of its own images of .jpg file. So, and one of the main advantages, let's say that you want to do some other type of classification. Let's say you want to find out whether there is pavement cracks or not. So it's also a binary classification. Only thing then you need to do is you need to change just the name of the folder and then put all your images accordingly. So you prepare your data set in the way that it matches the already benchmark data set, and then you can just use simply the code that is originally present here. Okay. Whereas on the other hand, if you are going with something like, let's say, like time series, then most of the time extracting the features is a task that you need to do completely on your own, which changes from like one time series to another time series. Whereas if you're doing this image classification, whatever is the image classification, you just need to prepare your data set in just this format, which is like very easy to do. So now, going further into the step one of, once you have downloaded the dataset, you have to prepare your dataset in such a way that carriers can automatically take it. So first of all, I am just fixing the image size as 180 cross 180 pixels. Batch size is at 32. Batch size takes like how many training examples it would take at a once to create to compute the gradients, and then one step of gradient is done. So it's something called a mini batch gradient descent, because whenever you are working with such a large scale data, you cannot put the entire data right away in the RAM. It is like too much computational resources, which often your RAM will not be able to handle. So therefore, what you do on the other hand is you just create like small batches, and you compute your gradient in these small batches and then update your gradient accordingly.